Hi again, guys. I just want to walk you through a few other things. So let's suppose we wanted to create a right triangle. Let's first create one of our legs. Suppose this is one of our legs. What do we need? Well, if this is one of our legs, we know that we need to construct a 90-degree angle through either this point or through either this point. So why don't we construct a perpendicular through one of those 2 points? Doesn't matter which one, really. But to do that, you see, construct perpendicular or parallel line. I need to select something other than this line segment. I need to also select, so I need to go to my selection tool, not just the segment, but also, let's say, this point. So now we can see selected 2 objects, this segment, this point. Now when I try to select perpendicular line, it goes directly through it. Fantastic. Okay, now all that remains for me to do is just to plot some point on this line somewhere. So if I select my point tool and put this there, so it's on the perpendicular line. You can see this in the bottom corner where it says on perpendicular line, right? And click, and now I've got a point. Okay, I complete my right triangle, or what I think is my right triangle, by selecting, by inputting a hypotenuse right here. Okay, so now how would we check if this were actually a right triangle? Well, we know that the Pythagorean theorem tells us that if we add together the sum of the lengths of the sum of the squares of the lengths of the sides, right? So if we had a squared, right, plus b squared, right, we should end up with c squared. Okay, so let's do that. Let's do that. So we're going to need the side lengths, right? Okay, so you guys remember how to do that? If you don't, right, we just are going to want to select the side length and make sure that's the only thing that's selected, and then measure the length. Okay, and if you guys want a trick here, right, if we select this, see now this is problematic, right? This is my entire line that's selected. That's not what I want. I'm not going to be able to measure the length of a line. Okay, I'm going to have to go through these 2 points and measure the distance. Same thing, measure, right, the length of a segment or the distance between 2 points. Same thing here. Okay, so you notice measure of segment, that notation, or this is another notation that we've used. Okay, and then I've got this last segment, so let's measure that. Okay, so I've got my 3 segment lengths, and I could pull out a trusty calculator and plug these in, but in fact, if we go to number, we see that there's a calculate function. Shortcut is apple equals, actually. So if we pull this up, we know that this is what we're trying to check it against. So if I just type in here a set of parentheses, and the nice thing is I can just drag or click these right in here. So suppose I want to, so that's my one leg, and then I'm going to square that leg. Okay, and then I want to add to that, and I just typed the plus sign, and I just typed another set of parentheses. This guy, and then square this guy. Okay, this tells me, all right, this is the left-hand side of my equation, right? This is my a squared plus b squared. So let's compare that against this side, squared. So again, let's just go back to my calculate, and I just want to click on this guy, and then squared, and we see that they've rounded them to the exact same thing. Oh, fantastic. This is fantastic. Now another cool thing about this is if I decide all of a sudden to move this point, I'm not going to move this point because if I move this point then I may end up disrupting my perpendicular. We can move that in a sec. But if I move this point, right, we notice that if I change the length of segment CB, right, it also affects the length of my hypotenuse. But as these change, we look up here, and my relationship stays exactly the same. So this is a nice way to check these kinds of things, okay? Because they'll stay relevant. Another thing you might want to do is kind of figure out, well, can I give these coordinate figures? Can I give these coordinate figures, or do they have coordinate figures? Well, if I right-click and go down to coordinates, they're just going to plot this on a grid and they're going to assign it some coordinate. So they're saying point C has coordinates negative 31 hundredths, comma 7.29. Right? I could right-click and select coordinates for point B too. Right? And similarly to these up here, I can move this, all right, and things will update. Okay. So let's do one other thing. Create a new one here, right? And let's suppose that let's suppose we wanted to construct an equilateral triangle. Okay, we wanted to construct an equilateral triangle with a side length of 7. All right. Well, if I were to just start and create a side length like this, I have no idea really. One way to do it obviously would be to then select this length or select this segment and then measure its length. Say, okay, well it's 21. Okay, so that's about 3 times too long. So I'll just adjust it back here, and I could totally do that. This is a little less exact. We can get pretty close, and see now I'm having difficulty getting it spot on. Okay, so I'm going to try something else. I'm going to pull down this define coordinate system. Okay, so I'm going to define the coordinate system, and now I'm just going to plot 2 points that I know are 7 units apart. Okay, so I'm going to come to graph, plot points. All right, and my coordinates. Well, let's just plot 1, 1. Okay, and then what's one point that I know is 7 units from 1, 1? Well, something either along the horizontal. Right, so that would be 8, 1, or something along its vertical, right? 1, 8. So either one. So we'll just choose 1, 8, and I just typed right in there. And I want to plot that. Okay. And to double check, right, I'm going to create a segment between these 2 points, and if I were to measure, remember I got to go back here to use my measuring tool, its length, 7 centimeters. Perfect. Okay, so now you're going to ask, okay, well how do I then go about figuring out where that next, I know that I have to make a 60-degree angle because an equilateral triangle has a 60-degree angle, but what about all the possibilities for a side length starting here that is 7 units in measurement? Well, remember that's how we define a circle, right? So if I select this point and I select my radius to be 7 units, right, because that's the length of that segment that I just constructed, right? This is the set of all possible points that are 7 units from this point. All right. I'm going to move this down so we can see this a little bit better. Okay. Now, well, this is the set of all the points that are 7 units from this point. So I know that the third point in my triangle has got to be somewhere on this circle. Maybe it's over there, or maybe it's over there. But it's probably not going to be over there. It's not going to be over there. That doesn't look equilateral. But if this side length is 7, right, then I need this side length to be 7 and this side length to be 7. I also need to say, well, what's all the set of points that are 7 units from this point? So I'm going to construct another circle, but I'm going to start it at this point this time, and I'm going to construct it such that its radius. See, now I know that if it's hovering over that point, that's 7 units away. That point is 7 units away. So now, when I look at the intersection of these 2 circles, here and here, right, this point is both, where these 2 circles intersect, is both 7 units away from this point, because it's on this circle, and it's also 7 units away from this point, because it's on this circle. So if I were to plot the intersection, right, and you notice that, so here I'm just on one circle, here I'm just on one circle, now I'm on both circles, and I plot a point there. Okay, so that would be one possibility. Or my other possibility would be right there. Okay? So if we construct this triangle now, bam, bam, okay? Let's measure these just to make sure. Okay, so I've got this one, and I'm going to also measure that one. Okay, measure lengths. And what does it show me? EC, great. Segment EC measures 7 units, 7 centimeters. Segment ED, perfect. Perfect, absolutely perfect. Okay, and what's the other thing that I should probably check? I should probably check these angles are 60 degrees. Well, I'm going to let you guys do that because I think we covered that in another video. Last thing I wanted to cover is just the fact that, again, if I want to move these things around, right, it is possible, if I'm getting this correct here. Oh, maybe because I started by plotting these points. Yeah, I may not be able to do that. But we should be able to, if I hadn't plotted these, and I'll just do this really quickly, right, if I hadn't plotted these, if I didn't want this necessarily to be fixed at 7, because I did fix this length to be 7 units, right, so if I just did this, here's some segment, and then, again, just doing the same thing, there's 1, there's 2, here's the point at which they intersect, and that's one side, that's another side, right? And now, if I want to change these side lengths, right? And we'll see if I measure these again really quickly, these side lengths, boom, boom, boom. I gotta deselect this point, but if I measure lengths, okay, so we got an 8.63 up there, right? So it's equilateral. And now if I just click and drag this, look at all those numbers. They change in sync. Okay. So the idea being that these circles change. These circles construct all the points that are uniform distance from a specific point. So you can use the same model to construct figures that are equilateral that have more than 3 sides, for example. Okay. All right. So I think this is good for now. All right. Bye.